Good morning and happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All righty. So today we're going to take a look at Section 2.6, Part 2. And so let's go ahead and get started. This problem says unmanned aircraft. I guess maybe those are drones. It says two remotely controlled unmanned aircraft are launched in opposite directions. One flies east at 78 miles per hour and the other west at 82 miles per hour. How long will it take the aircraft to fly a combined distance of 560 miles? All right, so we've got this starting point. We've got one aircraft that's flying, let's see, east at 78 miles per hour. We've got another aircraft that's flying west at 82 miles per hour. And the total distance, let's see here, is 560 miles. Okay, so let's make a table. Let's see here. And we'll say what distance equals rate times time. And let's see, we've got the eastbound and westbound. Okay, so the eastbound plane is traveling, let's see, 78 miles per hour, right? And the westbound plane is traveling 82 miles per hour. What do we know about their times? Well, if the planes left at the same time, which we assume they, let's see, what does it say here? Just says they're launched in opposite directions. I guess we're to assume they left at the same time. And then they headed off in different directions at different speeds, but at some time, they were exactly 560 miles apart. But the time they both traveled was the same. So let's call this time for the eastbound T and this time for the westbound T also, okay? So let's see here. What do we know about the total distance? Let's call this D1 and D2. The total distance is 560 miles, right? So it seems to me that D1 plus D2 equals 560, right? But what's distance one? It's 78 times T. Distance two is 82 times T. So we get the following: 78T plus 82T equals 560. 78 plus 82 is what? 150, 160. So 160T equals 560. Divide both sides by 160. And let's see, what do we get? Take out our handy dandy calculator here. 560 divided by 160 equals 3.5 hours. So there's our time. Okay. Let's see here. Let's take a look at another problem. This says photography. A photographer wishes to mix 2 liters of a 5% acetic acid solution with a 10% solution to get a 7% solution. How many liters of 10% solution must be added? I like to do mixture problems using boxes or just sort of containers. So let me get this drawn and then I'll explain what I'm doing here. All right, it says, a photographer wishes to mix 2 liters of a 5% acetic acid solution. So this would be 2 liters of a 5% solution with a 10% solution. So this is a 10% solution to, let's see, to get a 7% solution. Okay, how many liters of 10% solution must be added? So our unknown is this. Okay, so let me read it through again. A photographer wishes to mix 2 liters of a 5% acidic solution, so there's that, with a 10% solution. They don't tell us how much of the 10% solution, to get a 7% solution. Now, if I mix 2 liters plus X liters, how much do I have? I have X plus 2 liters, okay? If I take $5 plus $2, I have $7, right? But if I had $5 plus some unknown amount of money, I'd have 5 plus some unknown amount of money. Okay, well, where does this get us? This gets us to the following equation. 5% of 2 plus 10% of X equals 7% of the quantity X plus 2. I asked if there's any questions this morning, but there's nobody else here, so I'll continue on. I'm going to clear the decimals by multiplying everybody by 100. So distributing, I get 100 times 0.05 times 2 plus 100 times 0.10 times X equals 100 times 0.07 times X plus 2. Let's see, 100 times 0.05 is 5. So I've got 5 times 2, which is 10. 100 times 0.10 is 10 times X is 10X. 100 times 0.07 is 7. 7 times X plus 2 is 7X plus 14. So now, having simplified my equation, 10 plus 10X equals 7X plus 14. I'm going to subtract 7X from both sides and get 10 plus 3X equals 14. Okay. I'm going to take that and rewrite it. Let's see. Well, maybe I can just put it right here. 10 plus 3X equals 14. I'll subtract 10. 3X equals 4. Divide by 3, X equals 4/3. So this would be 4/3 liters, or 1 1/3 liters. Now, I think I mentioned this a few days ago, but just a reminder, in WebAssign, it doesn't tend to like mixed numbers. So if this was a WebAssign problem, instead of putting 1 1/3 liters, you'd put 4/3 liters, okay? What you don't want to do is this. Take 4 divided by 3, 4 divided by 3, and you get 1.3 repeating. And so you decide to round off and you write 1.3, and that technically is wrong. So go with the improper fraction in WebAssign. Okay, let's see here. Here is another mixture problem. It says coffee blends. A store sells regular coffee for $8 a pound and gourmet coffee for $14 a pound. To get rid of 40 pounds of gourmet coffee, a shopkeeper makes a blend to put on sale for $10 a pound. How many pounds of regular coffee should he use? So again, we've got this mixture problem. It says a store sells regular coffee for $8 a pound. So we're going to say that this is the, let's see, this is the $8 a pound. So that's the regular. And gourmet coffee for $14 a pound. $14 a pound. Let's see here. Gourmet coffee. And the stuff on sale is going to be $10 a pound. This is the mix. Okay. Now, let's go back again. A store sells regular coffee for $8 a pound and gourmet coffee for $14 a pound. To get rid of 40 pounds of gourmet coffee, so we've got 40 pounds here. A shopkeeper makes a blend to put on sale for $10 a pound. How many pounds of regular coffee should he use? So the unknown is the pounds of regular coffee. Well, if I take X pounds of regular plus 40 pounds of gourmet and I mix them together, I have X plus 40 pounds of the mix. Okay. So my equation becomes 8X plus 14 times 40 equals 10 times the quantity X plus 40. 8X equals, let's see here, 14 times 40 is, oops, that shouldn't be a plus or equal sign. It should be a plus sign. 560 equals 10X plus 400. And let's see, we'll solve for X on the left. So subtracting 10X, negative 2X plus 560 equals 400. Subtracting 560 from both sides, negative 2X equals negative 160. Divide both sides by negative 2, X equals 80. Let's see, what was the question again? How many pounds of regular coffee? So 80 pounds. So 80 pounds of regular combined with 40 pounds of gourmet. So they basically sold, what, 120 pounds of the mix. Okay. And let's see here. Here's another example. It says warehousing. A store warehouses 40 more portable. So basically the store keeps its stock in a warehouse. A store warehouses 40 more portables than big screen TVs and 15 more consoles than big screen sets. The monthly storage cost for a portable is $1.50. A console is $4 and a big screen is $7.50. Don't worry, I'm going to read this all again. If storage for all the televisions costs $276 per month, how many big screen sets are in stock? Let's see, what have we got? We've got portables. We've got big screens. And consoles. Okay. It says a store warehouses 40 more portables than big screen TVs. So portables are being compared to big screen TVs. So in that situation, you're comparing the portables to the big screens. The big screen would be the variable or X. Then it says, and 15 more consoles than big screens. So portables are compared to big screens and consoles are compared to big screens. So we're going to call the big screen, the number of big screens, X. Now, a store warehouses 40 more portables than big screens. So this would be X plus 40. And 15 more consoles. So X plus 15. Okay. Now, it says the monthly storage cost for a portable is $1.50. So we'll say monthly cost. What is that? $1.50 each. And console is $4. And the big screen is $7.50 each. Guess I don't need that fraction. So if we take the cost of an item times the number of items, wouldn't we get the total cost? So $1, come on. Well, this is good. There we go. $1.50 cost per portable times the number of portables plus 750, the cost per big screen times the number of big screens, plus the cost per console times the number of consoles. That would equal the total cost. And we were told that the total cost, where is it here? $276. Okay. So the cost of an item times the number of items, plus the cost of another item times the number of items, plus the cost of the third item, this is storage cost, times the number of items, equals the total cost. So here's our equation. I'm going to multiply both sides by, actually, I don't want to confuse you, but can you see that really I don't need to multiply by 100. I could just multiply by 10 because I don't need to move this more than just one place to get rid of the decimals. Okay, so I'm going to multiply both sides by 10. I could multiply it by 100, but then my numbers would be bigger than they needed to be. So distributing 10 times 1.50 times x plus 40 plus 10 times 7.50, 7.50 times x plus 10 times 4.00 times x plus 15 equals 276 times 10. So distributing 10 times 150 is 15, and that's times x plus 40, plus 10 times 7.50 is 75 times x, plus 10 times 4.00 is 40 times x plus 15 equals 2760. Distributing 15x plus, what is that, 600 plus 75x plus 40x plus 600 again, is that right? Equals 2,760. I'm going to check my arithmetic because yesterday I messed up on something I shouldn't have. So let's see. 15 times 40 is 600, and 15 times 40. Okay. So combining like terms, 75, 85, 90, 130x plus 1200 equals 2,760. Subtract 1200. 130x equals 1,560. Divide by 130, and let's see, 1560 divided by 130 comes out as 12. The question said, how many big screens are in stock? So the answer would be 12. And this would be what, 27, and this would be 52, but they wanted to know how many big screen TVs. So again, what's the basis for this equation? The cost per storing a portable times the number of portables, plus the cost per storing a big screen times the number of big screens, plus the cost of storing a console times the number of consoles equals the total cost. But before we could do all that, we had to set up these comparison relationships. Again, with a comparison, whatever's being compared to is typically at the end of the statement. That's what you want to have be the variable. All right, well, that's all I've got for today. And since there's no one here other than me, I guess I'll just say goodbye and hope you have a good weekend. A reminder, there's no school on Monday. It's Martin Luther King Jr.'s birthday celebration. So I will see you on Tuesday. I will be back at 1:15 with an office hour today. All right, have a good weekend. Bye now.